How you're doing on these problems. They want us to find the area and the perimeter for each figure and round to the nearest hundredth as needed, which means if it's trig, you need to round. Otherwise, you shouldn't be rounding. And if it's a 30, 60, 90 or a 45, 45, 90, you shouldn't be using trig because that's going to give you an approximation when you could give the exact answer. So on this problem, we've got a rectangle down here, so this is a 30, 60, 90 triangle. Because it's a 30, 60, 90 triangle, we can use those rules. This is going to be my short leg is S, the hypotenuse is 2S, and the long leg is S times the square root of 3. So S square roots of 3 is equal to 15. So we'll divide both sides by the square root of 3. And then rationalize the denominator. So it's 15 square roots of 3 over 3 is 5 square roots of 3. So for the perimeter, I usually start at the top and go around clockwise, but it doesn't matter as long as you don't miss any of them. There's 15, a 5 square root of 3, a 15, and another 5 square roots of 3. That gives you 30 plus 10 square roots of 3. And because the units were centimeters and perimeter is just a distance, it's just centimeters. For the area, it's base times height. So that's going to be 15 times 5 square roots of 3 is 75 square roots of 3. And since that's area, it's in square units, so square centimeters. This next problem involves using trigonometry for both the base and the height. So if we're trying to find the height, since it's opposite the 20, and we've got the hypotenuse, 24, that's going to be sine. So sine of 20 is equal to h over 24. Cross multiply and we get h is equal to 24 sine 20. I'm not going to calculate that yet because if I do, I'm going to round it off and then I could end up with what's called round off error, where you round it off and then used it for something else. So then for the base, that's adjacent and 24 is still the hypotenuse, so that's cosine. So the cosine of 20 is equal to b over 24. Again, we'll cross multiply and we get that the base is 24 cosine 20. So for the perimeter, I've got 24 cosine 20 at the top, and then on the side I've got 24 sine of 20. And on the bottom, I've got 24 cosine 20. And on the left side, we've got 24 sine 20. You've probably noticed that on rectangles and parallelograms for perimeter, you've always got 2 of something. If you want to save yourself some time, put it into your calculator. It's a lot faster if you do 2 times 24 cosine 20 plus 2 times 24 sine of 20. So we've got 2 times 24 cosine of 20 plus 2 times 24 sine of 20. Be sure that you close the parentheses after that cosine of 20, otherwise you're going to get an answer that doesn't make any sense at all. So that's going to be 61.52 square inches. Oh, excuse me, just inches. And then the area is base times the height. So that's going to be 24 cosine of 20 times 24 sine of 20. And again, it's really important that you close the parentheses at the end of the cosine 20. Did I miss a 4? Thank you. So it's about 185.12 square inches. For number 3, we can go and find the perimeter right now because we know that the opposite sides of this parallelogram are going to be the same. So there's going to be 2 18s plus 2 10s. That's 56. For the area, it's going to be base times the height. We have the base, but we don't have the height. If I use 18 as the base, I need to figure out what the height is. So we have a 45, 45, 90 triangle. So the legs are both short, and the hypotenuse is s times the square root of 2. So s square root of 2 is equal to 10. We'll divide both sides by the square root of 2 and rationalize the denominator. So it's 10 square roots of 2 over 2 is 5 square roots of 2. So it's 18 times 5 square roots of 2. 18 times 5 is 90, so that's 90 square roots of 2. For the units for perimeter, it'll be centimeters. And for the area, it'll be square centimeters. Okay, let's take a look at number 4. Part of what makes this one difficult is they don't give you all of the measurements. So I'm going to divide this up into a bunch of little pieces. If you don't need to divide it into that many pieces, that's fine. Some people can do it with less, but many people, they need to divide it up into lots of pieces. So starting up here at the top, we know that all of these are going to be little rectangles. So if this is 6, so is this, and so is that. And if this is 10, so is this piece. Now, if this piece is 10, how much does that leave for this piece? 8. So that's 8. This is 8, this is 8, and this is 8. And if this piece is 8, and this whole thing is 17, how much does that leave for this piece? 9. So this is 9. Then going back up here, if this piece is 6 out of the 20, that leaves 14 for these two pieces. And if that's 5, this is 5, and so is this. So for the area, we're just going to use base times height a lot of times. So I'm going to start up here at the top. I'll have a 6 times 8. I'll have a 6 times 10. That gets you both of these. We've got an 8 times 14. We have an 8 times 5. And a 9 times 5. Now, if you divided it into fewer rectangles, that's fine. You're going to have fewer area calculations. But since you're probably going to put all this into the calculator anyway, it doesn't really matter. See, that's 48, 108, 148, 193, 273. Trying to do it in my head just to see if I can. Is it 402? That doesn't sound right at all, does it? Gabby's like, no, it's not close. What is it? 300 how much? 305? Somewhere I went badly wrong. And that's going to be square centimeters. And then for the perimeter, I'm going to start up here and work my way around. So 18 plus 6 plus 10. That whole side is going to be 19. Plus this whole side is 17. Plus 5. Plus 9. Plus that whole side is 20. So 50, 60, 78. Is it 87? Okay, that was pretty bad. Let me see what I messed up. I'm curious now. So that's 50. That's 50, 68, 78, 88, 95. You say 104? Yeah. This is why I shouldn't just do things in my head. All right, one last problem. Just as a reminder, we did one of these in the notes yesterday, but this is an isosceles trapezoid. I know it's isosceles because these two sides are congruent. That means if I drop in an altitude from both of these top corners, I not only create a rectangle here in the middle, but these two triangles on either side are exactly the same size. So since this is a rectangle here in the middle, if the top is 12, this piece of the bottom is 12. Subtracting that from the 28 leaves 16. Cut that in half, and that means each of these pieces is 8. I still need to find the height, but it's a right triangle, and I know 2 of the sides. If you have your Pythagorean triples memorized, you probably already know what it is. If not, we can do it. It'll be 8 squared plus the height squared is equal to 10 squared. So that's 64 plus the height squared is equal to 100. So the height squared is 36, so the height is 6. So the area is 1/2 of base 1 plus base 2 times the height. So it's 1/2 of 12 plus 28 times 6. Let's see if I do better on this than I did on the other ones. That should be 120. Okay, any questions about that? Okay, so I have a worksheet for you.